Please read the question carefully. Show that the square of any positive integer is either of the form 4m or 4m plus 1 for an integer m. Here is one important tip that you should take the value of b in the Euclid division formula b is equal to 4 by seeing this format. Okay, let's get started. Solution 1. Euclid's division lemma for positive integers a and b is given by a is equal to bq plus r, such that r is equal to 0 or greater than 0 but less than b. Taking b is equal to 4, we get a is equal to 4q plus r, where r is equal to 0, 1, 2, 3. It is very obvious from this. When b is equal to 4, that means r can take the values from 0 and then 1, 2 and 3. Okay. So now you see, we shall denote this variable a corresponding to the r values 0, 1, 2 and 3 suffixes. So a0 whole square equal to 4q plus 0, which is the value of a0. And when we square it, we are getting 16 square equal to 4 into 4q square equal to 4mq, where m0 is an integer. It is because 4q square is again an integer and it is called 4m0 because of r is equal to 0. Similarly, we shall proceed for the other terms. A1 square is equal to 4q plus 1 equal to 16q square plus 8q plus 1 equal to 4 into 4q square plus 2q, and this one is remaining extra. So again equal to 4m1 plus 1, where m1 is integer. A2 square is equal to 4q plus 2 whole square equal to 16q square plus 16q plus 4 equal to 4 into 4q square plus 4q plus 1 equal to 4m2, where m2 is an integer. And similarly, you see this next result. A3 whole square equal to 4q plus 3 whole square equal to 16 q square plus 24q plus 9 equal to 16q square plus 24q plus 8 plus 1. 9 is split into two parts. Okay, for taking common 4 equal to 4 into 4q square plus 6q plus 2 plus 1 equal to 4m3 plus 1. m3 is an integer instead of this expression. Okay, and corresponding to the value of r is equal to 3. Thus, we have seen that in all cases, this is of this format 4 into some integer plus 1. And there also in each of the cases, we have seen that here 4m0, again 4m1 plus 1. A format is coming that either no remainder or remainder only 1. Okay. So take the conclusion from all these pattern, we can take a conclusion. Hence, the square of any positive integer is either of the form m or 4m plus 1 for some integer m. Okay. Please read the second question. Prove that n square minus n is divisible by 2 for every positive integer n. Here you have to understand one thing. You see that in Euclid's division lemma, we have got a is equal to bq plus r. So if we want to calculate a square minus a, then it is equal to bq plus r whole square minus bq plus r. This is one thing, and this is what the examiner and your questioner is saying in this question, which is equivalent to a square minus a. Okay, so we shall follow the pattern of the question. So come to the solution. Solution 2. We know from Euclid's division lemma that any positive integer is n is either of the form 2q or 2q plus 1, where q is an integer. Where q is an integer. Please see the I button video to realize this summary statement, which has been proved in an earlier easy problem, and it is useful to use in a longer and complex problems so that we can save our time. So okay, now n is equal to 2q implies n square minus n is equal to 2q whole square minus 2q equal to 2 into 2q square minus q, which is divisible by 2, because if you divide this quantity by 2, then 2 get cancelled, and this inside expression when reduced is giving an integer, so definitely it is divisible by 2. Likewise, n is equal to 2q plus 1 implies n square minus n is equal to 2q plus 1 whole square minus 2q plus 1 equal to 4q square plus 4q plus 1 minus 2q minus 1 equal to 4q square plus 2q equal to 2 into 2q square plus q, where 2q square plus q is again an integer, and here multiplied by 2, so it is divisible by 2. So you can write which is divisible by 2. Hence, proved that n square minus n is divisible by 2 for every positive integer n. I hope you have got the point.